Well, hi, thanks for joining me in my shop for another round with this radio. Focus today, well, we'll see how long the focus is maintained, but my plan is to try to investigate the hum or hums that are in this radio. And I'm going to start with a pretty good assumption that the hum is coming out of this power supply. So I think I explained at the end of the last video one of the challenges here, and I've done the basic hum hunt earlier and did not nail it down. One of the problems here is I think if you unplug the radio from the power supply, have no load on the power supply, the the hum cannot be detected. Anyway, what I'm going to do, never mind all that. Anyway, what I'm going to do is I'm going to turn everything on. I'm going to put the oscilloscope on the two B plus lines that come from the power supply to the radio. Excuse me, we're just going to look and see what we see there. So I think first I'll get the radio operating here. Everything looks okay. Okay, power on. Here we go. Oop, whoop, whoop, whoop. No power off. No speaker plugged in. I missed that instant hum that comes out of here. Okay, let's try it again. Excuse me. Instant hum. There it is. Now, one of my challenges here is I've got my right ear is completely blocked. I had the flu a month and a half ago, and since then I've had trouble with hearing, mostly in my right ear. So I'm mono today. I'm not stereo. Okay, so this is behaving the same as it was. I think I still have it on the antenna. Oh, still warming up. In fact, let's put it on full power here. That's a pretty powerful hum coming out of there. While it's warming up, I can get the scope set up. Let me do that. I want this on AC only. So we're setting this up so all I see on the scope is alternating current. I don't want to see the actual B plus on there. Oh, there we go. A bit of dirt there. So we'll put that line is this channel, and put that, and of course this one is the other channel, both set to 2 volts per division at the moment. How come I never heard the there we are. Let me show you what I just did here. So the radio was sitting like that. And I just okay, I'm going to keep it quiet until we need some audio if we do. So let's put the scope onto the B plus leads here. Radio's doing its best to receive. So I'm going to just clip these onto the chassis. I've verified that the chassis grounds are good. That's this black wire, by the way. This one here. Okay. Took one. onto the other. Okay. Sweep's going a little fast. Oh, wow. Two volts per division. 4 volts of hum here. 8, maybe 10 volts of hum here. Wow, that's just horrible. That's just horrible. Now how can that be since I boosted the capacitance up in the power supply? Good question. Okay, that was interesting because on the lower display here, which I guess has got to be this red wire. I'm pretty sure it's the red one. Let's just check. Yes, the red one. The red one feeds B plus to the output tube. And you can see the audio signals impressed right on that. That's fine. That's how the audio signal is making it over to the power supply. But you can also see, well, it's coming with this kind of hum on it. Okay. So, excuse me again. Just to convince myself of something, I want to pull all these tubes out and watch what happens to the power supply. Is there an easier way of doing this? So what I'm trying to do is I'm trying to remove the load from the power supply on the B plus side. I want to leave the filament loads on the transformer here. So I want to leave this plug in. So I pull out all these tubes. You know, that'll take away the heater load too, won't it? You talk too much, do something. Let's pull them out. And we'll watch the scope. I'll tell you which tube it is. Okay. There we go. Do the first RF tube coming out. Funny little bump in there. Why would I pull any more tubes out at this point? Because I want to see if I drop the load on the power supply, does the hum disappear? There should be an easier way of doing this. Okay, out comes the audio tube. Okay, that's pretty interesting. Yeah, put the audio tube back in. Oh, that was kind of interesting. Yeah, I'll pull out the detector tube now. So, put it back in. Let me pull out that audio tube one more time here. You can see exactly what I'm doing. You get a beautiful sine wave over there. Getting identical sine wave, size-wise. My hand right in front of the screen here. That's one on top of the other. Perfectly identical. So I think by pulling out the audio tube, I take the load off of the B plus line that's feeding the audio tube. just make these a little smaller here. Okay. Clip just fell off the radio. So let me put the audio tube back in. Put the clip back, test lead back on here. Well, you know, taking what load I've taken off, the power supply has shown no propensity to reduce the hum. Okay, next step. No, my earlier observation could be bogus. Oops. It happens from time to time that I'm not right. So earlier, my observation on the open circuit humming of this power supply, as I remember it, was there was no hum in the output, but then there'd be no load also. So let's try it again. So what I'll do is I'll just disconnect the radio. I mean, we're on our way to working on this power supply anyway. Okay, power supply. So the B plus are these first two terminals. So I'm going to reconnect the scope to those two terminals. I may have reversed the, did I? No, I don't think I did. I think I got the leads on the same way. Okay, no load. Here we go. So now, see, there's almost no hum. So that's how I made my mistake earlier. I tested the power supply with no load on it, and that's the result I got. And I said to myself, well, let's see, I've added in capacitors into the power supply, and I've checked, and there's no hum left. And but in the back of my mind, all the way along, I've wondered about how valid that really is, and it turns out not valid. So this guy's humming on the B plus. Now that should be easy to resolve. That's a very basic radio problem. There's almost in every older radio that has not been worked on. Hums in the power supply. I got to keep mindful of something else here. The only thing that really shows me the radio's on is this little light. The speaker's gone totally silent. And these tubes got to be getting B plus from somewhere too. How much you want to bet that when I plug the radio in, it pulls on the power supply, the hum appears, and that same hum, which is on both of these B plus lines, and there is only one original B plus voltage, by the way. It's divided to get it onto these two wires. And you saw that, in fact, when I took the load off, these looked identical. Take that back. When I pulled the tubes out, some tubes out, when I maintained some load, pulled some, you know, I'm not even gonna, anyway. Stick with the present, Jim. Don't worry about the past. So we got to flip this guy over. We got to take a look at how I put the capacitors in. Did I do it right? The original capacitors, which are inside this huge can. It looks like it's spot welded here. They're still connected, so that might be a problem right there. If these original capacitors are in really bad shape, so maybe there's a way of testing these too to find out. Okay, let's shut the power off before I do something dumb. Okay, so on the scope we can watch the B plus decay here. There it is up there. Not decaying very fast at all. So if the original capacitors in here are still connected, which I think they are, and they were terribly leaky, a couple things would happen. One is this voltage wouldn't stay up here where it is. It would come down quickly, or these capacitors would discharge the voltage very quickly. Number two, if they are drawing substantial current, I've never ever seen this happen, but if they were, because they're just really crummy resistors now, these things would get hot. There's never been any heat in this can whatsoever. Also, if these were putting a load on the power supply, then the hum would remain. If these were the cause of that large hum signal, and disconnecting the radio, that hum signal would remain, but it didn't. So another possibility is just simply insufficient capacitance. I should have put something way bigger in than I did. I think I actually put in capacitors that are bigger than the originals. You see, slowly this voltage is slowly coming down. So really, connected or not, I don't think these are an issue. What else can cause a hum? You know what can cause a hum? A bad rectifier tube. Bad rectifier tube. Oh, I was thinking about this the other day. I don't know if I've ever really... I think I tested this guy. Ooh, he's hot. Of course, rectifier tubes are always hot. This is a number 80. Made in Canada. General Electric. I've got some other ones. We better check this out. I have certainly had radios, small 5-tube radios, humming away. Change the rectifier tube, humming gone. I've certainly had that experience. On the other hand, I'm pretty sure this rectifier tube is good. So we're going to put the original tube there. Grab another 80. Okay, without testing it. Without putting it into a tube tester. That's a little bit anxiety oriented. Well, what I'll do is I'll switch on with my my lights here. Dim lights. Okay, we're all set. Scope not connected. Okay, here we go on lights. Nothing happened at all. This light came on. No heating on the tube. These tubes are heating. Okay, so I think this is a bad 80. It ain't no 80. Set him over here. Set him over there where I'll forget why he's over there later and put it back in my collection. Here's another 80. I had these on my bench, I guess, and I got them out to do this. Maybe I did this and I've forgotten about it. Okay, another 80. Ready to go. There we go. Bingo. This one's definitely heating up. It sounds exactly the same at this point. They'll have to wait for it to warm up, I'm afraid. Oh, I got a missing tube down here. Not going to work well with one tube missing. Take a look at the B plus voltage here. Okay, we give it full voltage. I thought it was 90 with the other two. 96. So if this tube is producing a lower B plus, the reason is it's dropping a lot of the supply voltage across itself. It's going to be running hot, and it is the bad tube. That's the tube we would want to get out. But the hub doesn't seem to be voracious, but also the radio doesn't seem to be working. What other dumb thing have I done here? I don't think anything. It could just be exceptionally low B plus. It's just too low. Okay, we'll switch back to the other tube, see if we can sort this out. You come out. A little hot already. In there. I think I did this once already, but no harm doing it again. Okay, here we go. I put the bad one in. Hey, put the bad one. That's why I put the bad one over there. There's the good one here. I shouldn't have said I was going to forget. That pretty much guarantees it, doesn't it? There we go. That's on restricted power, but put it on full. I'm fooling myself. I have two bad. I'm just swapping two bad rectifier tubes back and forth. What are the chances that's happening? It didn't say anywhere in the schematic that I can remember what the B plus voltage is supposed to be. It must say it somewhere. It must say it somewhere. That would be really weird if it, nowhere did it say that. I'm just calling up the schematic here to look at the power supply part of it quickly. Very quickly. Funny, it does not have a voltage written on it anywhere. Do you hear that? We hear that kind of stuff a fair bit out of this radio, where it just seems to pop into a slightly different mode. It's another thing I have in the back of my mind that I'm wondering what is doing that. So Well, schematic doesn't help out at all here. I'm just reading it very quickly. See if I can spot. No, it doesn't say anywhere. Okay. We have no idea if that's the correct B+. The radio essentially works with this tube in 87. I have another tube. Ooh, I don't know about this one. Yeah, back of the getter has gone white. See it in there? I think that suggests that this is a gassy tube. So normally the getter inside the tube looks the same through the glass or looking through the glass. It just looks basically like a mirror finish. Let's see this one here, same thing. Shiny getter area. This guy, he's white. Don't want to even try this tube. Okay, so are we sure about the number 80 that's in here? I think we're sure enough. The hum we're hearing is not coming from the number 80 rectifier tube. Well, all that's left then is a failure of the power supply to do its job. That's where we're left, and the power supply filter to do its job. So, shut them off before I go sky high. Here we can watch the voltage doing weird things here. Of course, the radio is plugged into the power supply, so it's drawing down to the best of its ability, probably while the heaters were still hot. Once the heaters cool off, these tubes all become open circuits, and once again the power supply is feeding nothing but air. So good, 5 volts. I feel pretty safe with that. So let's look under this power supply again. But maybe before we do that, another kind of wild guy source of hum is this transformer over here, which don't touch it, Jim. Sometime and very early on in the process of working on this radio, I discovered that moving this transformer, I can't remember how or the circumstances around it, but moving it a bit could bring a hum in and out. So another possibility is there's still something about this transformer, or it's returned to its hummy condition. It seemed to me it's just a mechanical contact underneath it. Let's take a closer look at this guy here. So this really looks like a rebuilt transformer. This all looks really quite new onto the old core. That's really what it looks like. These lead wires all look new. Looks like shrink sleeve has been used. So that would suggest to me the actual coil wire is coming out in here, and now it could be some joints, some splices right in there. So, you know, I'm gonna poke around with this thing. I should have the radio on while I'm poking around, even though it's a little bit of danger, as long as I'm careful, because I could do something here and not realize I've done it. That also almost never happens. But I think I'd be smarter to have the radio operating here while I poke around a little bit. Any reason not to do that? Well, there probably is some good reasons not to do that. But there's some good reasons to do it. Okay, let's power it back up. What I'll do is I'll power it up on with the dim light bulbs in the circuit. Just on the off chance that somehow I generate a heck of a short circuit in here. A little hard to hear the hum. Of course, I'm having trouble hearing the hum. Maybe it's maybe it's going like gangbusters in here. Maybe I already moved this transformer enough to eliminate the hum. Oh my God! You know what that means? I've got to get a. I got to hear the radio operated again before I go any further. Okay, full power. Is there some reason why this radio won't operate? No. All the tubes are in. Antenna's connected. This radio seems to take forever to warm up. Come on, baby, what happened? Okay, we're on full power. All the tubes are in. Just a wave of my hand. That's all it took. So what has happened here? This surely it should be going by now. Yeah, I don't want to proceed until the radio's working. I don't want to try fixing this thing until it's working. Who's messed up here? So I'm checking the antenna connections. I mean, everything is just the way it was. Huh. Now this guy usually makes a little bit of noise here. How come he's not? Heater's on. Okay, it's making some noise. What happened? So I touched this transformer a little bit. No, that can't be it. Fooling around with the 80, that can't be it. The voltage is there. I have a voltmeter connected. That can't be doing this. What has happened? Here we go again. This radio is just full of surprises. What else have I done? I've just moved things around a little bit on my bench. Come on. Hang on to your ears. Okay. Nothing coming out of here. Oops. Let me just check the heaters here. Heating. They're all heating up. Contact problem. Come on, little radio. Everything was going so well. Then I had to fool with it. I would expect if it's a tube contact at this point, it's not the heater. The heater's operating. I mean, one of the other contacts, cathode plate or a grid, if those contacts are a little wonky, I mean, you wiggle the tube, you'll know it right away. And this tube's output is definitely coming through the radio. Oh my God, how can this happen? You just get knocked back to square one all the time with this radio. There was that popping sound that we heard earlier that I mentioned about, that I've been a little curious about. I wonder if that was something popping off. I want it to pop back on now. Well, I can't stand here and do nothing. Let's start with a signal tracer. Signal tracer is on RF. Huh. Boy, I got something pretty cool in me today. Where the heck is that coming from? Wow. So what we're listening to is my signal tracer over here. Okay, let's put the ground on. That could be why I was hearing all that wild stuff. Wait. Wait a minute. All I did was move the radio over. TFSA. You hear him say that? TFSA? So in Canada we have special tax-free savings accounts. We're allowed to put $5,000, $5,500 a year into a special bank account declared to be a TFSA account. There's a few rules around the money in that account. Basically, anything you put in there, any interest you earn, you do not get taxed on. So $5,500, what's that? Well, you do that for 10 or 20 years, all the time compounding the interest tax-free. And these savings accounts are really, really powerful. So I think the American kind of version of this, or a similar system, is the 401k, I think, in the States. We also have another retirement savings vehicle here in Canada called Registered Retirement Savings Plan. This was an earlier system brought in by the government, and what you would do there is you take money out of your paycheck, stick it into this RRSP account. The government allows you to deduct that money from your income, so you're not taxed on it. It sits in that account, collects interest. I'm not sure if it's I think it's tax-free too. I think inside the RRSP. But then later, when you're older and you go to get the money, you pull it out, it becomes part of your income, you pay tax at that point. I don't know why I'm explaining this. If you're not Canadian, I'm thinking you might be a little bit interested in what goes on here. But the TFSA account that the guy mentioned on the radio, you never pay tax on that, ever. So when the money comes out, it's just money. You don't show it as your income. So TFSA, if you're Canadian, stick as much money as you can in one. Okay, enough of that. I think the reason I say this stuff about what goes on in Canada is because it certainly is helpful for me to find out what goes on in other countries, what systems they have, and how they handle these basic problems like retirement savings and stuff like that. It helps me understand what's going on here in my own country. There we are. That's why. So. Okay, what am I doing now? Now I'm really throwing myself off track here.
We buy a car, we have to buy car insurance. Yeah. We buy a house, we have to buy content insurance. Yeah.
So I know everything's working again just the way it was. That's what I wanted to be sure. I wanted to be sure that I hadn't monkeyed around with this transformer too much. And I wanted the radio operating, but we don't necessarily have to listen to it here. I can just detune that a little bit. Leave it operating. Oh, he's moved the radio again. Still working. Okay. Back to the transformer now. Well, what to do here? Poke around a little more. Poke around a little more. Give me a good strong poker. I really don't expect anything to happen here. But that's exactly when something happens. I'm looking at how these are done. Way down inside the can there. Hard to see, but right down at the bottom is a bottom plate with holes through it and rivets in the holes. And each of these wires heads through one of those holes or for one of those holes. Now it could be that there's the wire is actually soldered onto this rivet. I can't tell. It could be that's really just a terminal, and so on the underside we would find a terminal. But the thing is, here's the thing, that underside terminal, if it exists, is inside this can. It's not through the bottom of this metal can. So I see something kind of suspicious over here. Let me fire up my other camera. Just sit tight there while I turn on another camera here. Okay. Okay, look down in there. Okay, isn't that interesting? I don't know, is it? So we have the yellow wire here. So you can see it heading towards the rivet, and it looks like bare copper going into the rivet. But what's interesting is looking down lower, you see that red wire. So how is this can done? So I can see the retaining bolts here. Looks like a retaining bolt. Picture a screw coming up from the bottom under the chassis and bolting this down into it. I think I even see some threads on the edge of it. So this is actually the screw right here. And that would pull this can down. The bottom of this can is wide open? I don't think so. Okay, so let me get this turned right so you're not falling over. So you can see the a little bit better focus there. So this is the bottom of the can here. And it looks like it's folded over. It's got to be open to some degree. Wire's got to get out of it. What I'm thinking is it possible to just loosen off these nuts and this can will slide out and leave behind the transformer sitting here? That's possible, you know. Yeah, now a comment about the firewood here. Yeah. So if you're going to start a fire in a radio, the power transformer is one of the places where it could start. And you know, putting in some kindling here is not the best idea, I think. So if this can is bolted to the chassis, what's holding this transformer to the can or to anything? It's just these pieces of wood. That's it. And I really can't return this to the owner with pieces of wood in here. Why pieces of wood instead of what was originally there? Because what was originally there, I suspect, you know, this black crap, I suspect they potted the can, which in other words they put the transformer into it, got it in position, the leads coming out and everything, then filled this can with a black tarry compound, which somebody has painstakingly removed most of from the original transformer, or retained the transformer core, because these are hard to get, and you need these if you're going to rebuild a transformer. You got to start with this. They rebuilt the transformer, stuck it all back in, and then they didn't want to fill it full of compound. I mean, who would? So to make the transformer rigid, since there's no way to do it, this is me just making this up, there's no place to bolt the transformer to the can or to the radio. It's relying on the compound to hold it in place. Just imagine somebody getting this out of this can. Holy smokes. I'm complaining about what I've done to this radio. Whoa! Okay, so let's say they did all that. They put it all back together. You know what? I can see way down there. It's sitting on a piece of wood too. Look, there's a piece right in here. Don't forget this is operating. You can see what looks like a little ground lead or something right there. Some kind of little piece of wire coming out. So what if it's a simple matter of they clamp this baby down? Is there some more wires over here? I can see one down there. They clamp this puppy down and pinch the wire. And by moving things around, I actually freed up that wire. I've removed the pinch, at least the short. That red wire looks like a real candidate, doesn't it? Okay, so so what are we looking at? Is this the bottom of the can down in here? Or is that the top of the radio deck? See it over here, I think. Maybe through this crack here. Oh, look at that. Okay, so there's the wires. These ones showing up. The only way they show up is this can is open on the bottom. This can. It's open on the bottom. I think there's a chance you can get this can off with this transformer sitting here. Okay, so I'm looking at the, yeah, now I can really see it. I can really see it now. I can see the cut shape. So right under this, oh, this is a bloody nut here. This is a nut on top of a bolt. Well, maybe it's welded on. Maybe it's welded onto the tab. But what I want to get at is, you can see where the bottom of this can ends. Right. If I can, I'll turn around here. Right Well, you can see it. Believe me, I can see it. Well, look, you can see. Okay, so if this is the bottom, this is the top of the radio deck. See, you can see the hole. There we are. You can see the hole. You can see a green wire through the hole down there. So there's holes drilled into the radio deck. Wait a minute, this doesn't look like a... Oh my gosh, let me turn this around. I'm so turned around here myself. Yeah, when I look with my eyes, it's pretty clear. Because, you know, I look with my eyes, I get stereo. Okay. The stereo view, I can tell the top of the deck from the bottom of the can. Great. Okay, so we think we can slip this right off and the transformer would just be sitting there. Okay, that's great. That's what we're going to do next. It's risky stuff. Turn it off. If I turn it off, that'll reduce the risk. It's risky stuff because a big disturbance is coming here. Actually, I'm running low on kindling in my fireplace. Holy smokes, this has been shaped. That came out of there really easily. I don't know, somebody actually took, look at this. This is like a wedge. This is like a wedge with a fat piece stuck on it. What the heck is going on? He made a bunch of wood, glued it together, stuck it in there, and I just broken part of it. Wow, is that ever rough? Okay, let's pull this out. Maybe the guy was thinking, this will be in a can, nobody will ever know what I did. Let's pull it out. Okay. There's a little bit of glue at the bottom here. I don't know what he was trying. Okay, so that's it for the wood, except there's a block right underneath the transformer. How loose is it now? Completely. Wow. You know what? Wow. Yeah, that's what. This red wire I was concerned about being pinched. You can see a little tiny piece of it there in the camera. It actually sticks out the other side of this can. Actually comes right out, you can see it. That is probably the short right there. Okay, so let's think about this. What am I trying to do? I'm trying to make sure there's no shorts or funny business in here. Am I trying to just take it apart for fun? No. Too many risks in this, for sure. All kinds of problems getting this out of here without making a mess. And to what advantage? To no advantage. What I'm trying to do is eliminate a squeeze type short. That's got to be it down there. Let's see if we can move the red wire. Yeah, see, this can is down pretty, it's solid. It's really solid. So if it's solid onto that wire, I'm not going to be able to move it. Get a little more light. You know, it's bent in there fairly tightly anyway, so moving it is really quite a challenge. I think all I got to do is loosen the can here and here, pry it a bit up, then work this out from underneath, then drop the can back down and we're done. I need to look at this thing from the other side, completely from the other side. If I turn this over, the transformer's going to fall right out. Yeah, you know what? This lets me move that red wire enough to see for sure it's pinched right in there. Doesn't mean it's definitely the short. There's a good reason to look underneath. See a little bit warm, just a little bit. Nothing at all that you would think is a problem. Okay, so can I turn this upside down? If I do, wow, what a challenge. I got to turn it upside down. I got to hold this in place. I'm going to have to wedge it. I can do it. I think I can do it. More famous last words. I think I can do it. I think I can. Let's disconnect everybody. Let's pull the plug right out of the outlet here. There can be no mistakes made there. So from what I've seen, I don't think the hum we're hearing has anything to do with the transformer wire we're looking at. I think when I wiggled it and jarred it and things cleared up, so many 100 videos ago, I think that was the fix. I don't think there's anything else wrong. How do I know? Okay, let's take these guys out before we boot them up. I have no replacement for these two. These are 71A tubes. I have no replacement for them. The owner of the radio purchased some tubes. One of them was labeled 71A, so he thought he was getting another 71A. When I got it here in my shop, it turns out, yeah, that's what it was hand labeled, but what it actually was a different tube. So still no spare 71s. Okay, over you go. I suppose it can probably hang from the wires because there's quite a few wires, as much as I don't want it to do that. Where'd my nice little piece of wood go? So this is really a lot of weight on here. It's really pushing up. Okay, we'll take a look at what we've got here. Okay, so the red pinched wire, I think, is this. I'm trying to remember which corner it was in. Wasn't it in this corner back here? There's the big screws. Let's look around with a close-up camera here. And give me a second here. I'm going to max out the focus on it, so we can get up pretty close. Getting my own big screen going here. Okay, there we go. So this slot that you see is the slot through which the wires are coming. This is a slot cut in the base plate of the power supply. So you're actually able to look up past the slot. Can't see too much up there. I'll improve the lighting in a moment. Let's just stick up here. So this red wire, if this is the pinched guy, there. Wow, what a snake. Connects to there. Okay, so that is one of the resistor networks for feeding the heaters. I think this is a cracked wire there. Look at that. Ah, twisted wire all cracked up. Ooh. See, the cloth insulation is intact, so not to panic over this, but oh my god, this goes way up into this scary chasm up here. Oh wow, look at that. It's not looking terribly healthy, is it? I don't want to touch any of these right now, because if they're causing a problem and I move these around, I got to make it worse or make it better and not even be aware of that that's what's happening. So that's the plunger for selecting what your line voltage is. There's the no, that's the speaker output. Take that back. That's the speakers. So this is the speaker wire we're looking at that is so badly cracked. This speaker, here it is here, has this great big transformer on it. Big coil. So that says, without looking at it any closer, the high voltage is being fed right up to the speaker. I'm not so sure that that's true, but it could be. So, you know, can a cracked wire on the speaker lead cause a hum like we see in the power supply? No, I can't see how that could happen. Oh boy, that looks... Ooh, I'm moving it apart here with that. I'm using the camera to do it. Let's separate them. Okay, wait a second. Just a little crowded in here. Where'd they go? Get the light right. Look at the flat spot on the other wire there. Okay, let's separate them. Ooh, did you hear that little click? That was the insulation cracking somewhere, I'm sure. Do you see copper? Well, that's pretty ugly though, isn't it? I don't know, you know, surely a short circuit is not going to be good in any case. What am I supposed to do about this? Replace all these wires? Ay, ay, ay. Wow, goes way down there. I don't think I'm gonna try that, because disaster would result. I could do something to kind of separate these. Wow. I don't know, what do you think? Wish I could hold still. Now, I can't get any closer than that, I don't think. Let's see if we look at the other wire. If I can. Because they both have to have a complete insulation failure. As for leakage of current, you know, these are, well, if this is a 100 volt circuit, 100 volts, maybe something can leak there. But if it's just low voltage, it just can't be anything of any concern. Generally, when you have low voltage, you have high current anyway, so a little tiny leak somewhere. Wow. I just don't think this can be the source of a hum. Again, I at least should have the thing operating if I'm going to poke around like this. That's a wee bit scary. Just to take a look at how fine this wire actually is. This wire wound resistor. So right here, whoops, I don't want to touch it. The insulation's missing. Right, you can see it sticking around the edge there. So the wire itself is extremely fine. That one's a little heavier. What is that? Is that a wire or is that a hair? What is that? Looking at it with my eyes, it looks like a piece of, I'm going to have to just grab it here. No, I think it's a piece of string. I think it's a piece of string. Let's see. Yeah, I'm sure that's a piece of string. A wire wouldn't behave that way. Okay, it's nothing. Okay, going back to the to this situation over here. Just fix the focus so we can get down there a little further. Okay, there. So why is there all that big blob of solder there, down inside here? So I'm looking now for other wires that might be pinched or anything that might, hard for me to spot this. And maybe when I moved the transformer, I did something else. It has nothing to do with the red wire. Maybe something else. These all look to be in excellent shape. You could do a lot to these wires and nothing would happen. So I think I should just do plan A, which is loosen off these screws, let the plate drop a bit, fish the wire out from underneath, and we're good. I have to figure out how to fix this transformer in place. Look like this red wire, the one I've been tracing. It doesn't look like it goes where it can get pinched by the cam. There's no other red wire. It's right in the right spot, isn't it? Wow, let's look again. It doesn't look right. So this is the red wire here. I've got to change the focus again. Now it looks like that's the end of the wire, and there's some horrendous soldering thing happening there, with strands all over the place. What is all that? What is all that stuff? Is that more of that stringy stuff? Over here, that looks like wire strands on a difficult solder job. Could have easily been one of those wire strands. Well, let's see. Can I get in there? So when I look with my eye, what I see is a huge terminal here. This is all one terminal. This entire shebang here is one big soldery blob. Wow. And, you know, here's what I see with my eye. Ooh, what's going on here, computer? Not sure what happened there. Okay. I'm looking in here. I mean, this just isn't a very big little hole. Yeah, I don't, you know, I just can't give you the same impression I can get with my eyeballs, as much as I'm trying. It just looks like a big whopping terminal now. There's something there I can grab, pull out and look at. And so that's a piece of fiber. It's not a piece of wire. Those are definite wire strands from, I'll say, difficult solder job. What could those touch? They could touch the frame of the transformer, or they could touch the bottom plate here. They could touch the can. The shame is I've got another camera coming. Don't know if it'd be helpful in a situation like this, but I hope it would be. It's coming. It's still coming. It's not here yet. It's coming by mail, of course, from China. Just hasn't made it here yet. But that would be handy to stick down in a spot like this. Okay, not to get overly focused on this one spot. Maybe there's more in here to find. I'm still not convinced this red wire is the one that's pinched. If this red wire is not the one that has the strands, then what's got the strands on it? That's right, so the transformer, I'm thinking about this now, I'm trying to picture this properly. The transformer leads are coming up this way, going through little rivet holes. They could be terminating in those rivets. Those rivets are actually terminals, which makes perfect sense. And then another wire is soldered onto the terminal and brought up through the little hole here. So that would explain this red wire not appearing to go. It's got to be the one. It's got to be. Or was it here? I gotta look again. I gotta flip this whole thing over. Think about it. Look it over just for a peek. Okay. Wow. Okay. Completely and utterly wrong. Completely and utterly wrong. But not now. Okay, so the red wire that's pinched is this one. There's actually two slots here in the bottom plate. The slot over here is covered by this resistor, wire wound resistor. This is the wire that's pinched. That means I got to loosen off these two screws. Yeah, I should be able to loosen off these two screws, pull this out, pull the slack up into the back of the bottom of the power supply here, pull it, and then tighten them down afterwards. Now this is on a nut. If that nut is actually free, no, it doesn't feel free. It must be soldered or welded or something to that. Because if it were free, I'd have another headache here. Oh my gosh, what's going on here? I have to apply major muscle strength. Wow. Okay. Well, that was just down as... wasn't a lot of screw through the... So I'm going to loosen off these other two corner screws here on account of... That'll allow the plate to tip. Allow the can to tip. If I don't loosen these off, no tippage. Okay, shouldn't take too much here. Okay. This is the one that really needs to be loose. Pushing down should push the can. Yep. Back this up quite a ways. You want to squeeze it down. Let me change this a little bit here. A little bit of a bigger shot. So we're going to squeeze down this. This will push the can up off the wire. Now I want to pull this wire out. There, did you hear that? There it is again. So I'm pretty sure I pulled this wire out from under the can. Close up because I see something already. Okay, now see the insulation cut right in the middle of the screen there. How bad is that? Is that just a line, or is that actually cut through? I'm going to try to bend the wire to expose it a bit if I can, or pull on the insulation or something. Well, it certainly looks like a place where the wire was being squeezed down. I can't see the cut, but then, you know, it's because of the way the wire's bending. I'm trying to get it to open up here. Now this wire, is it just rubber insulation with nothing else? I think it is. I think so. This wire has nothing but rubber insulation. So if you manage to pierce this rubber insulation, you are hitting the conductor. These older wires are actually better because they have the inside silk or whatever the material is. And so there's another spot way down in there. I'm never going to be able to see it though. Now, how do we know for sure? How do we know anything for sure? How do we know for sure? That's one of the issues in life, isn't it? One of the general issues. We're going to have to take a look. So I'm going to pick this guy up, flip it over, take a look, and put it back. So detangle everything here. Okay, if I'm going to drop it, I want you to get a good look at it. So I'm going to put that camera on. The wire appears to have disappeared entirely. Wait a minute. Oh my, okay. Let's put this down and take a look. Oh my. Oh my. Imagine the guy who did this transformer, did all this work on this transformer. Hey, my ear just popped open. Ah, I got stereo again. How do you like that? Great. The guy who did all the work on this and then screwed himself. I'm sorry to say, but that's what this looks like. Let's take a look at the screwage. Oh, I'm not looking at it with that camera. I gotta look at it with this camera. Let me just make the focus right here, because I got focused a little too close. Okay, I should do it. We almost need a drum roll for this. Da, 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 da. I didn't get the focus quite right. Here, we can get it down in there. Holy schmoly. Well, okay, so that's what was underneath the edge. Okay, did it make a cut all the way through to the conductor? Does it have to cut all the way through to the conductor? Can it just get really, really close and that's enough to cause electricity to travel? Depends on the voltage. It depends on the how sensitive the circuits are. At the bottom end of that, you can see a black spot. Don't think that's a conductor. Well, the good thing is I pulled it out. I pulled it out of its danger spot. We can, you know what? It could be ruined underneath. We're squeezing down from the top. We're squeezing up from the bottom. The top here's got a knife edge slicing into it. The bottom's got a flat plate pushing up on it. And you've seen a few wires affected by the flat surface thing. This has to be the hum that I accidentally cleared, and I have the feeling it was still cleared. It certainly is now. Okay, so we're in business. We're in business. Okay. Where are we on the clock? Oh my gosh, an hour and 22 minutes has gone by. 10:15 in the morning. Okay, I got a little more time. A little more time. Now this transformer is now free to walk around in here. Okay, can't forget that. Screws are still loose underneath. I should tighten them up. Okay, let me do that. Okay, the wire pincher. No more pinching. Ouch. Put this back like that. Okay, everybody ready to put your money down now. Did that clear away a hum? Did that clear away a hum? I think I got this earlier on much earlier on. I think I cleared that hum problem much earlier on. And now what I just did now only secures the situation. So with a little bit of banging around, it won't reestablish itself now. I don't know if that wire's shorted on the bottom. I really didn't do anything to get it off the bottom, well, I moved it around. I moved it around enough that it was squeezed down hard. Now it's floating up probably not shorting it. Even if it is, wrapping this a couple of times, we'll find out pretty quick. So I'm excusing myself from looking at that now. Get the firewood out of here. I bought a cord of firewood to burn this winter. Last winter I bought a face cord. This winter I bought a full cord. Full cord is 3 times a face cord. I've been having fires every night. My fireplace, I have a nice fireplace, rec room. And it's in the basement, so extra heat it actually all works. I got more than half the wood left here and not half the winter left. So I'm going to have a garage full of wood. I thought I was going to burn it all. Now, back to concentrating on the matter at hand. Let's put this voltmeter back on, only because I can. Just so we can spot the B+ voltage when it comes. Everything else is back together the way it was. I run a risk of having introduced a bad short, but the risk is really low in my opinion. Almost really quite the opposite, in fact. Put the antenna back on here. Let's take an aerial view of the situation. Speaker's plugged in this time. Scope not connected. That's okay. I think we're ready. I think we're ready. Okay, so we'll hit the power here using the dim lights again. Here we go. Why so different? Hardly any hum come out of that speaker. Maybe that's a good sign. Okay, look at this. Can't really look at it. 106. 106 and I haven't got full voltage on it. Okay, so something has happened. Is it a good thing? Turn up the volume here. Volume's up. Still it's a slow warmer upper. Coffee time. There's less hum maybe because these aren't warmed up yet. This might be high because they aren't warmed up also. Don't think so though. I think we got a new B+ voltage. This is great. I think we're really cooking this time. I'm not putting it on full voltage just yet. We're running at around 80% of 120, 90, 95 volts. Okay, I hear a little radio ticking, clicking. I'm so impatient. I never had a radio take this length of time to come around. It makes me wonder if it's something other than the heating up of the tube. If it's maybe a capacitor slowly charging up, something like that. Okay, let's see what we got here. By gosh. Let's give it full voltage at this point. Look at that. That was it. That was the problem.
Now, when you get to what I do, to do what I do, then we really don't have any hours. I mean,
We try
Oh,
to
man.
take a little time off from time to time. Like, for example, I get 4 weeks vacation every year, and last year I ended up with 4 weeks vacation. I never used any of it. And the previous year was the same thing. Now, everybody, you see, I love what I do. So, stress is not something that I use or consider to define, my dealings in the car industry. Sometimes working in the car industry gets pretty intense. Like, it's been really intense over the last 4 weeks. We didn't get the numbers that we wanted.
Let's tune around a bit.
Here, and, we... I always talk about negative, situations here. What the show is all about. Remain anonymous.
Let's go back. 2 minutes of advertising on that station.
When the end of life came on, the end ceased. And they called me. He said, Fred, what can I do?
Okay.
And I said, well, that's easy. If you have gone to the dealer and done every service at the store, and you have all your records, 102,000 kilometers with a relationship will put you within the goodwill category.
Tuning.
So you don't have to
Alignment.
worry about it. Just go and talk to your dealership. Take it to the dealership, and they'll look after you. That's easy. And he said, I didn't. And I said, what do you mean I didn't? He said, well, I never went to the dealership because I felt that it would cost me too much money. So I took it to local
Feedback.
places for oil changes. And I said, okay, fair enough. Now this makes it a little... What you do is to provide me with all your invoices, and I will guide you to the place that you need to go and speak to the dealer for them to help you. And he said, well, I don't have them. And I said, what do you mean you don't have them? And he said, well, I went to various different places, and many of them I don't remember. So I said, okay, when was the last time you did an oil change? And he said, well, I don't remember either. And what happens is this, that now, eventually we got all the documentation, but this, for the sake of saving, $3, $4, $5 an oil change, he potentially put himself at risk of spending almost $15,000 on an engine. And, I'm sorry because this person is a friend of mine, but the level of negligence, the level of silly, I was going to say stupidity, but that's it's a bit too harsh of a word, so I'm not going to say it. I often don't understand people. I don't understand it.
One of the things that Calvin sort of mentioned is that people only look at their 2-week pay area. They don't look ahead of anything else. So when people's bills are so tight, they're like, oh, if I can save $5, $10 here, they don't care what's going to happen to them.
Now I've got a resonant antenna on here, the loop antenna. Now I'll switch it to the wire antenna. We'll see what happens.
That potentially some $10,000 on the line. Now, what happens if the vehicle had a recall
Okay.
that would qualify them to change the oil or to change the motor without at any cost, but they never found out about it? Folks, please be smarter.
Loop antenna off. Chunk of wire. Chunk of wire antenna. Insufficient chunk of wire. Laying on the floor. Loop antenna.
Is that, customers do take advantage of dealers all the time. So if
Wow.
you establish a good relationship with your dealer, you have a good service advisor that guides you the right way, that's worth some money. Sean, I don't want you to go anywhere.
Well, it's been a long session, so I'm going to cut it here. Fantastic. That's it. This radio is working. Oh, fantastic. I got to deal with the speaker now in two ways. One is, what about this cone? I'm inclined to just leave it as it is, as rough as it looks. But what I really need to do is put the cover cloth, the grill cloth, on. Wow. Well, I'm going to have a good day. I hope you have a good day too. Thanks so much for watching this exceptionally long video. And see you on the next video. Hey!